This next lesson is about the percent equation. Essentially, it's the same exact thing as what we just did with the proportion, but instead of writing a proportion and then using the Hart method to solve, what we're actually going to do is just write an equation, and then we'll just be solving a straight-up equation. One thing that you do need to notice, it was really easy with the percent proportions because we just dropped the percent sign off of your percent number. In the percent equation, you are going to have to change your percents to decimals, which is what this box right up here talks about. Also, if you are looking for a percent, you're going to end up getting a decimal. So I gave you a couple examples up here of what's going to actually happen. So what number is going to be represented by x is signaling to us that we have an equal sign. 50% needs to change to 0.50. Of reminds us to multiply by 6. So really when I write out this equation, I have x equals 0.50 times 6. So I would just do this, x equals that. So I would get 3. In the next one, 3 is what percent of 6? 3 equals what percent gives me x of times 6. So in this case, to get the x by itself, I'm actually going to have to divide by 6 on both sides. Final example, 3 is 50% of what number? So 3 equals 50% changes to a decimal times what number? So we put in x then. So our equation is down here. To get x alone, you would divide by 0.50. In number 1, let's go ahead and take a look at it. So it says what number, that tells me we have an x, is now signals to me we have an equal sign. 12% would be 0.12. Of means times, and then we have the 150. So x equals 0.12 times the 150. You may want to just use parentheses for your times in this chapter just because we are going to be working with a lot of decimals. So it just kind of keeps things a little bit safer. So if I do the 0.12 times the 150, I actually end up with an answer of x equals 18. X is already alone, so I just have to do this here. Example number 2, 21 is equals what percent? So we're going to say x of means times 40. So 21 equals x times 40 isn't how I'm going to write it. I'm just going to actually write it as 40x. So to get x alone, I have to divide by 40 on both sides. And if I do 21 divided by 40, I get 0.525. Keep in mind it said what percent. So this is actually the decimal version. So 0.525, I need to move my decimal point over, so it's 52.5%. That's the only reason that sometimes these become a little bit trickier then versus the proportions. In example 3, 13 is equals 26%, 0.26 of what number? So times what number is telling me I need an x. 13 equals 0.26 times x, 0.26x. Divide by 0.26 on both sides to get x alone. And if I do that, I end up with x equals 50 then. So it's of what number? It's of 50. In example 4, a survey found that 25% of young adults gave up their home phone and use only a cell phone. If 3,264 people only use a cell phone, how many people were surveyed? So basically what we're saying is this number, 3,264, is the 25% of people surveyed. So we know this is my equal sign. 25% goes to 0.25 times, we don't know how many people are surveyed, so we're going to say x. So our equation is really 3,264 equals 0.25x. So to get x alone, we divide by 0.25. So I get 3,264 divided by 0.25. So I learned that x equals 13,056. So there are 13,056 people surveyed for this survey then. And it makes sense, this is a small portion of it, so it makes sense that my answer is larger. A local bakery sold 60 loaves of bread in one day. If 65% of them were sold in the afternoon, how many loaves were sold in the afternoon? So the 60 loaves in one day, that's my total. So 65% of 60 loaves were from the afternoon. So we're trying to figure out what is that. So what is 65% of 60? So x is equal to 65% of 60. So all I'm really having to do here is just multiply the two together. I'm going to get 39 loaves sold in the afternoon. So on the next page is something similar to what we're going to do in class. So if you have missed class, this will kind of take the place of that. What I want to do is compare to you how the proportion works versus the equation. So I'm going to do one of the examples, and then I'm going to have you actually stop and practice with the other ones. The purpose of us showing you this is just to kind of get you thinking, which method do you personally prefer? Because you are going to start to make a choice in this chapter about which one you would like to do. There really is no right or wrong way. It's just making a choice about which one works better for you. So my first example says, what number is 70% of 45? So what number is 70% of 45? So if I'm thinking back to proportion, 100 goes bottom right, percent goes above it. What number is tells me is gets an X spot of 45. So remember, it's is over of, percent over 100. So I could set it up that way and solve. So I would get 100x equals 45 times 70, which would be 3,150. Divide by 100. And x equals, if we do that, 31.5. Or I could say to myself, okay, what number represents x? Is means equals 70% of 45. So my equation is x equals 0.70 times 45. In this case, multiply, I also get 31.5. So you'll notice with the equation method, most times you're going to actually skip this first step and you'll end up with something similar to just solving a basic equation. In this case, it was just a straight up multiplication problem. That's why I personally have a tendency to go for the equation method, but in some instances the proportion method is a little bit better. So what I'm going to do is I'm going to stop talking, but I'm going to actually set up the proportion and the equation for you here as well as down here, and then I will actually give you an answer for it as well. So if you want to try and work while I'm doing this, or if you want to pause the video, work, and see if your answers line up, that would be perfectly fine as well. So here's the first one. Second one. So there you go.